Hi guys, welcome back to my YouTube channel. In this video, we take a look at the Wassce 2025 Elective Mathematics questions on Section A. Question number 1. Given that x combination 2 plus x combination 3 minus 4 is equal to 0, where x is a positive integer, find the value of x. Solution. Suppose we have n combination r, then this expression is equal to n factorial divided by r factorial, then n minus r all factorial, right? And so here, if we have x combination 2, then this is equal to x factorial divided by 2 factorial, then x minus 2 factorial, right? Likewise, x choose 3 is giving us x factorial divided by 3 factorial, then x minus 3 all factorial, right? And so let's substitute this into our expression. So from the question, we have x choose 2 plus x choose 3 minus 4x is equal to 0, right? Now here, x choose 2 is given by this expression, and also x choose 3 is given by this expression. So let's substitute these guys in here, then we simplify our results, right? Thus, we are going to have x factorial divided by 2 factorial, then x minus 2 all factorial plus x factorial divided by 3 factorial, then x minus 3 factorial minus 4x is equal to 0. And so here, our goal is to simplify this expression, right? X factorial is giving us x times x minus 1 times x minus 2 times up till we get to 1, right? When we take a look at this expression is just the same as x minus 2 factorial, right? And so we can rewrite this as x times x minus 1 times minus 2 factorial, right? Likewise, when we take this expression we can rewrite it in terms of this, right? Likewise, we can also rewrite x factorial as x times x minus 1 times x minus 2 times x minus 3 so we get to 1. So when you take a look at this expression here, this is just x minus 3 factorial, right? And so we are going to have x times x minus 1 times x minus 2 times x minus 3 factorial, right? And so here, in place of x factorial, we are going to write this expression here. And also in place of x factorial, we are going to write this expression here, right? As this expression is now going to become, so we have x factorial, which is now x multiplying x minus 1, then x minus 2 factorial divided by 2 factorial is 2, then x minus 2 factorial plus, so we have x factorial, which is now giving us this expression here. So you're going to have x, then x minus 1, x minus 2, x minus 3 factorial divided by 3 factorial is 6, then x minus 3 factorial, right? So now we went through all these because we want these guys to cancel out, right? And so here we are going to cancel out these terms. So when you cancel out these terms, you are going to have x times x minus 1 divided by 2 plus x times x minus 1, x minus 2 divided by 6 minus 4x is equal to 0. And so our next step is to multiply through by 6 in order to get rid of the fractions, right? So in doing so, we are going to have 3x times x minus 1 plus x times x minus 1, x minus 2 minus 6 times 4 is 24, so that will be 24x is equal to 0. And so we now solve this equation, right? From these two terms, we can factor out x times x minus 1. So doing so, we are going to have x minus 1 out, then 3 plus x minus 2 minus 24x is equal to 0. And so here, when you simplify this, you're going to have x plus 1, right? So that's, you're going to have x, then x minus 1, then x plus 1 minus 24x is equal to 0. So here we are going to factor out x from these two terms, right? So doing so, you're going to have x out, then you have x minus 1, then x plus 1 minus 24 is equal to 0. And so here we have x is equal to 0, or x plus 1 times x minus 1 minus 24 is equal to 0, right? So now let's solve this equation here. So we are going to expand this, and this is the difference of two squares. So this will simply become minus 1 minus 24 is equal to 0. So x is equal to 0, or x is equal to this guy, right? So here we are going to have x squared minus 25 is equal to 0. So we have x squared minus 25 is equal to 0. That's x squared is equal to 25, right? So this implies that x is equal to plus or minus 5, right? But from the question, we are told that x is a positive number, right? Hence, our result is giving us x is equal to positive 5, right? And so this is the value of x from question number 1 in this example. With our second example, we have a function of f is defined by, so f of x is equal to 72 divided by px plus r, where p and r are constants. Given that f evaluated at 6 is equal to 12 and f evaluated at 7 is equal to 9, find the values of p and r, and also find f inverse of 5 on 3. Solution. So here we have f of x is equal to 72 on px plus r, right? Now we have f of 6, that's f evaluated at 6 is equal to 12, and f evaluated at 7 is equal to 9. So now let's find the values of p and r, right? So first of all, we have when x is equal to 6, the function value is equal to 12, right? So that's when x is equal to 6, f of x is equal to 12. And also, when x is equal to 7, we have f of x is equal to 9, right? So now let's take the first one. So we are going to substitute in 6 in place of x. Then we set our right hand side to be equal to 12, right? So we have f of 6 is equal to 72 divided by p times x, but x is equal to what? 6, right? So you're going to have p multiplying 6 plus r. And this function value is equal to what? 12, right? So we have here to be 12. Now let's simplify this guy here. So we are going to have 72 divided by 6p plus r is equal to 12, right? So we are going to cross multiply, then we simplify our results. So this will multiply this, and this also multiply that, right? So we are going to have 12 multiplying 6p plus r is equal to 1 times 72 is 72, right? And so we can now divide by 12, right? So dividing through by 12, you're going to have 6p plus r is equal to 6, right? So this is our first equation, right? Likewise, we are going to substitute in x is equal to 7, then we set the right hand side to be equal to 9, right? Then we simplify. So now we are going to focus on this guy, right? So we are going to have f of 7 is equal to 72, then x is not 7, so that will be p times 7 plus r is equal to 9, right? So that's we have 72 divided by 7p plus r is equal to 9. So every whole number is divided by 1. So then you cross multiply. So that's going to give you 9 multiplying 7p plus r is equal to 72, right? So now we now divide through and see what you're going to have. So when you divide through by 9, you're going to have 7p plus r is equal to 8. So we have our second equation, right? And so here we are going to solve these two equations simultaneously, right? So let's call this equation, say, equation star. Then we call this equation, equation double star, right? So here the coefficient of r is 1, and that's of the coefficient of r here is 1, right? So we can subtract these two equations, right? So now let's subtract equation double star from equation star, right? So we are going to have 7p plus r is equal to 8, then minus, we now subtract 6p plus r is equal to 6, right? Here we have 7p minus 6p, that's going to be 1p, of which we just write p. Then here also you have r minus r, that's going to give you 0. And then here you have 8 minus 6, that's going to give you 2, right? And so here we have the value of p to be equal to 2. So once we have the value of p, we can now substitute p into either equation star or equation double star in order to find the value for r, right? So now let's substitute p is equal to 2 into equation star, right? So we have 7p, of which p is equal to 2, plus r is equal to 8. So that's going to give us 14 plus r is equal to 8, right? Thus r is equal to 8 minus 14, right? And so r is equal to minus 6. So we now have the values for p and r. Hence, f of x will be giving us, so we have 72 divided by px, but p is now equal to 2. So that will be 2x. Then r is now minus 6. And so this is the expression for f of x. Now let's move on to find f inverse of 5 on 3. So here our goal is to find f inverse evaluated at 5 on 3, right? So here we can solve this in two ways, right? We can first compute f inverse from this expression, then we evaluate it at 5 on 3, or we can set this expression to be equal to x, then we solve for x. So here let's use the second approach. So we are going to say that let f inverse of 5 on 3 be equal to, let's say, x, right? Now, since we have here to be f inverse, so if we find the composition of f on both sides, since f inverse and f, when you compose it together, you're going to have the identity operator. This term will just be 5 on 3, right? So we are going to have f of f inverse of 5 on 3 is equal to f of x. So the left hand side is going to be just 5 on 3, then is equal to f of x. But what's f of x? F of x is what we have here, right? So we now substitute this guy in here. So then this will now be equal to, thus we have 72 on 2x minus 6, right? Then we can now solve for x. Thus we have 5 on 3 is equal to 72 on 2x minus 6. So we can cross multiply, then we now solve for x, right? So we're going to have 5 multiplying 2x minus 6 is equal to 3 multiplying 72. So we are going to have 10x minus 30 is equal to 3 times 72 is going to give you 216, right? Now let's solve for x. So you move this guy to the right hand side, then you simplify. So you're going to have 10x is equal to 216 plus 30. So that's 10x is equal to 246. Hence, x is equal to 246 divided by 10. right? And this is equal to 123 divided by 5. Thus, we can say that f inverse of 5 on 3 is equal to x, right? But x is now equal to what? 123 divided by 5. So this is the value for f inverse. With our next example, we are to resolve 2x minus 7 divided by 25x minus 24 minus 6x squared into partial fractions. Solution. So here we have 2x minus 7 divided by 25x minus 24 minus 6x squared, right? And you have to resolve this into partial fractions. So it's best we write the highest exponent term first. So we can rewrite this guy as 2x minus 7 divided by minus 6x squared, then plus 25x minus 24, right? So we can factor out the minus from the denominator in order to make our work simple for us, right? So that's going to give us 2x minus 7 divided by minus out, then the denominator is going to be 6x squared minus 25x plus 24, right? So that's we have minus 2x on 7 divided by 6x squared minus 25x plus 24. Good. So we can now easily resolve this into partial fractions by finding the factors of the denominator, right? So here we are going to factor out the denominator, giving us 6x squared minus 25x plus 24, right? So here to find the factors, you find the products of 6 and 24, which will be 144. Then you find factors of 144, when which you add, you're going to have minus 25, right? And so this is going to be minus 9 and minus 16, right? So we are going to have the expression to be 6x squared minus 16x, then minus 9x plus 24. Then you can now easily simplify this, right? So simplifying this, you are going to have 3x minus 8, then 2x minus 3, right? So this is going to be the factors. And so you can rewrite this expression as minus 2x on 7, then divided by 6x squared minus 25x plus 24, right? This is equal to, the numerator stays the same, then the denominator is now giving us this expression here, right? So that's going to give us 3x minus 8, then 2x minus 3, right? And so we now find the partial fraction decomposition of this guy, right? Thus we have minus 2x minus 7 divided by 3x minus 8, then 2x minus 3, right? Since the factors in the denominator are linear, we are going to use a on, then this one is going to be 3x minus 8 plus b on 2x minus 3, right? Because the factors are linear. And so we now simplify the right hand side. So you find the LCM, which will just be the same as this guy here. So that will be 3x minus 8, then 2x minus 3, right? So then when you simplify this expression, you're going to have a will multiply this guy here. So that will be 2x minus 3 plus, then b will also multiply this guy here. So that will be b 3x minus 8. So we have the left hand side to be minus 2x minus 7 divided by 3x minus 8, then 2x minus 3. So here we have the denominators to be the same, right? Which implies that the numerators must also be the same. So we equate the numerators. So that's going to give us minus into bracket 2x minus 7 is equal to a, then 2x minus 3 plus b, then we have 3x minus 8. So here our next step is to solve for a and b. So you pick a number, right? When which you substitute either a or b will go to 0. Then you can now solve for the other variable, right? So here let's choose x to be equal to 3 on 2. So for x is equal to 3 on 2, what are we going to have? So in place of x, you're going to substitute in 3 on 2 in this expression, right? So that's, we have minus, then 2 times 3 on 2, then minus 7 is equal to a, then 2 times 3 on 2 minus 3 plus b, then 3 times 3 on 2 minus 8. This will cancel that, so you're going to have 3 minus 7 will be minus 4, minus minus will be plus, so you're going to have this side to be plus 4, right? And then we move on to the right hand side. So here this will cancel down, so you're going to have 3 minus 3, which is equal to 0. So here this term will be equal to 0, right? Then we move on to the b part. So you're going to have b, then we have 9 on 2 minus 8. So we now have to simplify this expression, right? So that's going to give us 4 is equal to b. 9 on 2 minus 8 is going to give us minus 7 on 2, right? So simplifying this, you have b to be equal to minus 8 on 7. So we now have the value for b. Right? To solve for a, b must go to 0, right? So let's choose x to be equal to 8 on 3, right? So then we substitute x is equal to 8 on 3 into this expression. So you're going to have minus 2, then 8 on 3 minus 7, right, is equal to 8 times 2 on 8 on 3 minus 3, then plus b equal to 3 times 8 on 3 minus 8, right? So now let's simplify this guy. So that will be minus 16 on 3 minus 7 is equal to a, then we have 16 on 3 minus 3. And so here, this will cancel down. So you're going to have 8 minus 8, which is 0. So b term will go to 0, right? So we now simplify this, then we solve for a. So in doing so, we are going to have a to be equal to 5 on 7, right? So we now have the value for a. So we are going to substitute these values into a partial fraction term, right? So we are going to have the partial fraction to be given as a is now 5 on 7, so that will be 5 on 7 divided by 3x minus 8, then plus b is now minus 8 on 7, then divided by 2x minus 3. And so we can simplify this guy further. So we are going to have 5 on 7, then 3x minus 8, then minus 8 on 7, 2x minus 3. And so this is the partial fraction decomposition, right? Hence, the partial fraction of this guy is equal to 5 on 7, 3x minus 8, minus 8 on 7, 2x minus 3. Thank you for watching. See you guys in the next video. Bye.